All right, here's my last example for dilations. And in this example, it's kind of weird because our center of dilation is actually the same as our coordinate E. Wow, that's so weird. Well, let's draw it in anyway. I'm gonna use a different color. I don't know if you can tell. And then I'm still gonna write COD next to it. So let's pretend like, we're not really sure how to do this, but we're just gonna do it the same way we did the other problems. So our center of dilation was -6.2, and our scale factor, it says right here, is 3. So we always start at the center of dilation. So how would we get from the center of dilation to E? Well, that's an interesting question because we are there. Like the center of dilation and E are the same exact coordinate. So we would actually go left, right, up, down, 0. Like you don't move, you're there. So remember, whenever we're trying to find how to get to E prime, we would take our distance, which is 0, and we would multiply it by the scale factor. Well, 0 times 3 is 0. So we literally do not move. When the center of dilation is the same as a coordinate, it's actually also going to be that coordinate prime. They're the same. So that was uneventful. So now from the center of dilation to F, I'm going to count. So I would go up 1, 2, 3 over 1, 2, 3, 4. So up 3, right 4. And now I can apply my rule, center of dilation to F prime. So I'm going to go up 3 times K, and to the right, 4 times K. And in this case, K is 3. So it's going to be 3 times 3, which is 9, and 4 times 3, which is 12. So starting at the center of dilation, I'm going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to go to the right 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that point is going to be F prime. And now if you actually draw your line from the center, or from E prime to F prime, sorry, I have to flip this over. This is an example. You see how I drew over my original line? In this example, we would say that EF and E prime F prime are coinciding, or another way of saying it, the same line. Now, I'm not saying their distances are the same line. I'm just saying they're in the same linear plane. So like they're still in this general area. Now, that doesn't mean they're equal in length. Obviously, EF only goes from here to here, and E prime F prime is much bigger. So they are coinciding. That just means that they're on top of each other. So if this pen and this pen were parallel, they would be like that. If they were coinciding, they would literally just be in the same plane. They would be in the same linear area. So I can say that they're coinciding, and then I can still say all the same things about their distance. So I can say my original one, which was the shorter one, would equal the longer one if I just cut the longer one into fourths. Or another way of saying that is if I multiplied this little guy by 4, it would give me the length of the bigger one. So this is just an interesting case where my center of dilation was the same as one of my points, which means it actually won't change, but point F will still get farther away.